In this section, we are going to discuss derivative of polynomial and exponential function. So first, we start with derivative of a constant function. So we have a function y equals to 3. It is a horizontal line. Since the slope of horizontal line is equals to 0, so y prime is just equal to 0. And then the power rule is extremely important. So the power rule, the derivative of x to the n is n times x to the n minus 1. So let's say y is equals to x to the 10th power. What about y prime? Y prime is equals to, you bring the 10 down, and then you take the x raised to the power minus 1. So that is 10 times x to the 9. Let's practice a couple more of this. So let's say we have y equals to x to a 1/2. What is the derivative? Again, we are not using limit definition. We take the 1/2 down, and then x raised to 1/2 minus 1. So that is 1/2 raised to negative 1/2. So let's say you have y equals to x to the negative 6. What about y prime? Y prime, you bring the negative 6 down, and then x to the negative 6 minus 1. So you have negative 6 times x to the negative 7. Let's do one more. All you have to do is you have to get used to this. So let's say y equals to x to 126. You don't want to have do the x plus x raised to 126 power, right? That is going to take 10 hours to do one derivative. So y prime, you take the 126 down, and then x raised to 126 minus 1. With some practice, you don't need to write the minus 1 out because no one wants to see that. So y prime is 126 x to the 125. So that is the simple power rule. The next one is called constant multiple rule. So if you look at the derivative, by the way, the d dx is called the derivative with respect to x. All right. We have c times f of x equals to cf prime. So this, let's say you have y equals to 10 times x to the negative to the third power. Make it simple. What about y prime? So the constant multiple rule tells you that you can simply take the derivative and ignore the coefficient when you bring the power down. So you write 10, you just take it aside, you bring the 3 down, and then x to the 3 minus 1. So y prime is equals to 30 times x to the second power. So let's say you have y equals to 5, x to the negative 6. So when you take the derivative, you simply put the 5 right there. You bring the negative 6 down, and then x to negative 6 minus 1. So you have y prime equals to negative 30 x to the negative 7. And then the sum rule and the difference rule, there is nothing interesting. If you have y prime equals to x squared plus 6x to the 10th, you simply take the derivative of the x squared and the derivative of 6x to the 10th. Let's see if you can do it without the minus 1. So this is a 2x, right? You bring the 2 down, 2 minus 1 is 1. And then plus, you bring the 10 down, right? 6 times 10 is 60. And then x to the 10 minus 1. If you change that to a minus, y prime, let's take another problem. Let's say 2x to the 5th minus 3x to the negative 7. So you bring the 5 down, 5 times 2 is 10, 5 minus 1 is 4. And then you bring the negative 7 down, minus 3 minus 7, you have a plus 21. And then negative 7 minus 1 is negative 8. And then finally, you have y equals to e to the x, and then the derivative is still e to the x. For the e to the x, it doesn't matter how many times you take the derivative, it's always e to the x. So that is the basic rules of taking derivative. So let's do a couple problems. So let's differentiate this. So in part A, we have a f of x is equals to 3 to the 50. Is this a constant function? Of course, 3 to the 50, I know that equals to a huge value, but there is no x in it. So this one is just equals to y is 3 to the 50 power. It's a constant function. It's a straight line. The graph of this is y equals to that huge value. So it's a horizontal line, straight line and horizontal. So the slope of a horizontal line is 0. So f prime of x is equals to 0. All right. And then b, we have f of x equals to 5.2x plus 2.3. This is a linear function, right? This is a linear function. What is the slope of this linear function? It's equals to 5.2. Another way to write this is 5.2 times x to the first power plus 2.3. So let's find f prime. So f prime is equals to, you bring the 1 down, 5.2 times 1 is still 5.2. And then what about 1? 1 minus 1 is equals to 0. And then the derivative of 2.3 is one constant value, right? Constant. We are going to use this word a lot. What is constant? Constant is one real number only. There is no x attached to it. 2.3 is linear, right? It's a horizontal line. Horizontal line. So that means the slope of 2.3 is 0. So plus 0. So you're only left with 5.2. In fact, the slope of this linear function is equals to 5.2. What is f prime? F prime is a slope. We are just looking for a slope. So that is your answer. And then C, we have f of t equals to 2t to the third minus 3t squared minus 4t. If you're not comfortable with no exponent, you can put a 1 in there. So this is 2. You bring the 3 down, right? And then t to the 3 minus 1. Since this is our first couple problem, I will show the minus 1. When you do your work, you get used to this. You don't need to show the minus 1. Minus 3, bring the exponent down, and then the exponent minus 1. Minus 4, bring the exponent down, exponent minus 1. So you have a 6t squared minus 6t, and then minus 4. So that is your f prime. Oh, I forgot to do the write the f prime. So f prime, this is your f prime, and then I want you to box your final answer. That's how easy it is. D, we have g of x equals to x squared times 1 minus 2x. So first, we have to distribute. So x squared minus 2x to the third power. This is a polynomial, right? So the slope changes all the time. And then your g prime is the 2. You bring the 2 down, x to the 2 minus 1. Leave the 2 alone, bring the 3 down, x to the 3 minus 1. So you have 2x minus 6x squared. That is your g prime. What is g prime? G prime is the slope of g at any x value. And then E, we have R of A, 3A plus 1 squared. This we have to open up the parenthesis. So that is a 3A plus 1 times 3A plus 1, right? So that is equals to 9A squared plus 3A plus 3A, you have a 6A. And then plus 1, and then we are ready for the derivative. So R prime of A, we bring the 2 down. So 9 times 2, A to the 2 minus 1, we write it out. And then this is a 1, right? So 6, bring the 1 down. And then 1 minus 1. 1 is a constant, right? The plus 1. Plus 1 itself is a constant. What is the slope of 1? The slope of 1 is 0 because 1 is a horizontal line. So plus 0. The slope of 1 is equals to 0 because 1 is a constant. Simplify that. Plus 6. Done. 18A plus 6. And then part F, you have y equals to 3 times e to the x plus 4 divided by the cube root of x. This we have to rewrite the cube root. So this is a 3e to the x. What is a cube root, by the way? 4 cube root is 1/3. How about exponent in the denominator? So that is a negative exponent, right? E to the x plus 4x raised to negative 1/3. And then now we do the y prime. So we have 3e to the x, and then plus, keep the 4 in there, bring the negative 1, 3 down, and then x to the negative 1, 3 minus 1. So that is equals to 3e to the x, and then minus 4 over 3, and then x to negative 4 over 3. So I usually keep negative exponent. To me, negative exponent is fine. If the class that you are taking requires you to put the exponent in positive, then you have to do this. Then 3e to the x, and then minus 4 divided by 3, and then you have to put this back to the denominator. So there is a 1/3, right? So you have a cube root of x to the 4th. So let's do G. Part G is function h of u is equals to a times u to the 3rd minus a b, big B, right? Big u square minus 2cu plus 10. Hey, what is the independent variable? The independent variable is u, right? So right here. So the 10 is just a constant. So we have h prime of u. So we bring the 3 down. So that is a times 3, right? 3a u, and then 3 minus 1. Bring the 2 down. 2 times a is 16. B, and then u 2 minus 1. And then the u, this is a 1, right? You bring the 1 down, 2c, u to the 1 minus 1. The derivative of 10 is 0. Because 10 is a constant, you can just write the 0 out. So h prime of u is equals to 3a u square minus 16bu minus 2c. That's it. That is your final answer. All right, moving on to more complicated problem. Let's change colors for that. So part H, we have y equals to x squared minus 4x plus 3 divided by square root of x. This one we have to simplify first. So we have x squared divided by x square root is 1/2 power, right? And then minus 4x divided by x to a 1/2 plus 3 divided by x to a 1/2. And then we have to simplify the power. So this one, what do we have? We have x 2 minus 1/2, 3/2, and then 1 minus 1/2, 1/2. And then this one, we don't have any power to subtract, and that will be 3x negative 1/2. And then we are ready to take derivative. So y prime is equals to, you bring the 3/2 down, and then 3/2 minus 1. 4, you bring the 1/2 down, and then 1/2 minus 1. And then 3, you bring the 1/2 down, and then x to the negative 1/2 minus 1. And then you clean up the subtraction for me. So y prime is equals to 3/2 x to the 1/2 minus 2 negative 1/2, and then minus 3/2 x to the negative 3/2. I prefer to use a negative exponent. I don't know what your class prefer, but when I ask my students to do everything on paper, I accept negative exponent. But when you do your homework, especially if you are doing homework online, make sure you check that system. Maybe they do not take negative exponent. You have to check the system. And then part I is a similar problem. So part I, you have f of v. So v is an independent variable. So the cube root of v minus 2v, and then e to the v, divided by v. So you have v to the 1/3 divided by v minus 2v e to the v divided by v. So you have v to the 1/3 minus 1. 1/3 minus 1 is negative 2/3. And then this one, the v got cancelled, e to the v. And then you simply take derivative. So f prime of v, that is equals to, you bring the negative 2/3 down, and then v to the negative 2/3 minus 1 is negative 5/3. Or maybe I should not skip my step, so negative 2/3 minus 1, I write out for you. And then the derivative of e to the v is always e to the v. Alright, so we have f prime of v that is equals to negative 2/3 and then v to the negative 5/3 minus 2 e to the v. So that is your final answer. Before we get to the next one, I want to discuss an extra problem. This problem I didn't type it up. So let's say we have this one, and just make a special problem for you. So let's say we have f of x equals to e to the x plus e. What is the derivative? The derivative of e to the x still e to the x. What about e? E is approximately equals to 2.71. So without the x, without any exponent, e is just a constant without exponent. So this will be plus 0 because e without any exponent is just a constant. Hey, how about this? How about e to the 10? E to the 10 is still a constant because 2.7 raised to a 10th power is a constant. Alright, so now we move on to the next problem. So let's do part J. So part J, we have z equals to a divided by y to the 10 plus, not equal, plus b e to the y. So sometimes when you look at check out a problem on the book, they do z equals to, but I don't really like this way because if you have a z equal, then which one is a variable? We can argue, right? Is a variable or b a variable or y a variable? But if you do this z of y, then there is nothing to argue. Then we clearly know that y is a variable. So that is a to the times y to the negative 10 plus b e raised to the y. So your z prime of y, you bring the negative 10 down, and then negative 10 minus 1, and then b e y is still b times e to the y, right? Constant rule. B is a constant, so when you take the derivative, you can ignore e for now. You can just take the derivative of e to the y, which is still e to the y. So that's why you have b times e to the y. So your z prime is negative 10a, and then y to a negative 11, and then plus b e y. Oh, this one I can put the 11 back to the denominator for you. So 10a divided by y to the 11, and then plus b e raised to the y power. So that is your z prime. So that will be all for the basic introduction. In the next part, I will show you how to find a tangent line to the curve of a function at a given point. So I see you in the next part.